Hi everyone. So we're going to get started with some work today. So hopefully if you can, you've printed out these notes that I posted on Classroom. If not, you're following along with a piece of paper that's going to go in the note section of your binder. Again, I don't want you using spiral notebooks. Okay, so the first thing we are going to cover are like terms. Okay. What are like terms? Definition of like terms are terms that have both the same variable and the same exponents. All right. Just a quick review of some vocabulary. If I have a term 3x to the fourth, okay, the x is of course the variable, okay. Variables are represented by letters. The 3, the number in front of the variable, is called your coefficient. And the 4 up here, that's called your exponent. All right. Exponents are always above variables. Okay. So again, in order for terms to be like, they have to have both the same variable and the same exponent. So what we want to do first is we want to look at this chart. We're given two terms. We want to say, are they like terms or are they not like terms? Let's take a look. Okay, negative 6b and 6b. Are they like terms or are they not like terms? Well, they certainly have the same variable. They both have b's, okay? Do they have the same exponents? Well, remember, this is a coefficient, this negative 6. It's not it's not an exponent. The exponents here, even though they're not written in, are understood to be 1 and 1. So yes, they have both the same variable, they're both b's, and they have the same exponents of 1. So yes. Okay. The next one, 2x squared and x to the third. All right. Are they the same variable? Yeah, they both have x's. Do they have the same exponents? No. This one has a 2, this one has a 3, so no, they're not like terms. Okay, next, negative y and negative 3y. Same variable? Yeah, they're both y's. Same exponents? Again, don't get fooled into thinking this negative 3 is an exponent. It's not. The exponents are really 1s. Okay? So we do have the same variable, and we do have the same exponent, so yes. Okay, next, 10x to the third and x to the third. Same variable? Yeah, x, right? Same exponent? Yes, they both have exponents of 3 or cubed. So yes, they're like terms. Okay, next one, decimals, but doesn't matter. Do they have the same variables? Yeah, x and x. Do they have the same exponents? Yes, remember the ones up here. So they are like terms. Next, negative 2 and y. Do they have the same variables? No, the negative 2 doesn't have a variable. It's called a constant. Okay, so no, negative 2 and y are not like terms. Last one, 5x and 3x. Same variable, yes, they both have x's. Same exponents, yes, they both have those ones understood to be up top. So yes, they are like terms. Okay, so that's identifying like terms. Now combining them. If they are like terms, remember, this is only going to work if they are like terms. Non-like terms can't combine. Okay. If they are like terms, like by doing what we did above, we're going to combine them by adding the coefficients. Okay, and coefficient, again, going back here in this, we said the 3 was the coefficient here, so the 3 is the number in front. Okay. So number 1, combine, if possible, negative 6x plus 12x. So step 1, are they like terms? Yeah, they are. They've got the same variable. They both have x's, and they have the same exponent of 1. So we're going to combine them. So negative 6x plus 12x. Okay, we're going to combine the coefficients, the negative 6 and the 12. And negative 6 plus 12, positive 6, right? So when we are, you should remember, when we're adding numbers that have different signs, we're really subtracting. So 12 minus 6, 6, and we're keeping the sign of the larger one. The larger one's the 12, it's positive. So this is going to be positive 6x. All right, number 2, combine if possible, negative 4c and negative c. Okay. What we want to think of here is this is really negative 4c minus, when you see just minus c, that's minus 1c. Okay, so now we need, they are like terms because they both have the c's and they have the same exponent of 1 up here, right? We don't really need that. So we need to combine the negative 4 and the negative 1. So an integer rule you should remember is when you have the same signs, because this is negative, that's also negative, we're going to add, so 4 and 1, 5. So this is going to be 5. And we're going to keep the sign we had. The sign we had are negative and negative. So this is going to be negative 5c. Okay. Number 3, are they like terms? Yes, they are. The fact that they're decimals doesn't change that. Okay, so 0.8x plus 2.2x. We're just going to, again, combine the coefficients. And 2.2, 0.8 is 3.0. So we're just going to write that as 3x. Okay. Number 4, negative 2z plus 2y. Are they like terms? No, they're not. So we can't do anything with this. So our answer here is just going to be not possible. Okay. Again, non-like terms can't combine. Number 5, negative 2x plus 2x. Are they like terms? Yes, they are. So negative 2 plus 2. Okay, so we're adding with different signs, negative 2 and positive 2. When we have different signs, we subtract. 2 minus 2, 0. Okay, and of course 0 doesn't have a sign. So we don't want to write it as 0x. We just write it as 0. Negative 4r minus, parentheses, negative 8r. Okay, are they like terms? Yes, they are. They both have r's and the same exponents. Over here, where we have this double negative, you should remember this changes to a positive. So I'm going to rewrite it as negative 4r plus 8r. Okay, same sign or different. We have different signs, so we're going to subtract. 8 minus 4 is 4, and we keep the sign of the larger. The larger one is the positive 8, so it's going to be a positive 4, r. Okay. Do a little bit of erasing. All right. The next thing we want to do is review how to evaluate algebraic expressions. So evaluate means substitute and use the order of operations, which of course is PEMDAS. Okay. So by substitute, we mean replace. So in number 1, it says evaluate when x equals -3, 2x minus 12. So in this algebraic expression over here, I'm going to substitute x with -3. So we're going to rewrite it as 2 times -3 minus 12. Okay, so we have multiplication over here and then subtraction over here. In PEMDAS, the m comes before the s, so we're going to multiply before we subtract. So 2 times -3, positive times negative makes a negative. When the signs are different and we're multiplying, we get a negative. So this is -6 minus 12. Okay, now we're subtracting, and we have the same signs because this is negative, that's negative. So your rule for that when you subtract with same signs, and by the way, I have a whole flow chart with all the sign rules. If you need it, I will post it on Classroom. Okay, so we have -6 minus 12, same sign. So the rule for that is add, so 6 and 12, 18, and keep the sign you have. So your answer is -18. Okay, number 2, evaluate when y equals -4, y to the second minus 10. So we're going to start by substituting for y. That's going to be -4 squared minus 10. So -4 squared, remember, that means -4 times -4. Okay? And when we multiply with the same signs, negative times negative, that gives me a positive, which makes our answer 6. All right, number 3, evaluate when x equals -1, x squared. So we're going to write -1 squared plus 4 times -1 plus 3. Okay, so we have an exponent. This is an exponent. This is a multiplication, and this is addition, right? So the first one in the order of operations as e. Okay, e comes before m, and m comes before a. So we'll do it in this order. -1 squared means -1 times -1, which is +1. Then we're going to multiply 4 times -1, -4, and plus 3. Okay, 1 minus 4, -3, plus 3, which is 0. Next, evaluate when c equals 3, c to the third minus c plus 10. So we're going to substitute 3 to the third minus 3 plus 10. Okay, so we have an exponent to evaluate here. 3 to the third means 3 times 3 times 3. Okay, 3 times 3, 9, and then times 3, 27. Okay, 27 minus 3, 24, plus 10, 34. Okay, our last question, evaluate when d equals -4, parentheses d minus 4 squared minus 1. So we're going to substitute d with -4. So we're going to write, instead of d, -4, so -4 minus 4 in parentheses squared minus 1. Okay, so I'm going to rewrite PEMDAS over here. Now, notice we have parentheses here, so we need to do what's in the parentheses first. So negative 4 minus 4, same signs, you add 4 and 4, 8, and then keep the sign you have, so that's going to be negative 8 squared minus 1. Okay, now we need to do our exponent. Negative 8 squared, which means negative 8 times negative 8, negative times negative, positive. So 8 times 8, 64, minus 1, which is 63.